Okay, so the last thing we want to do tonight is look at proving our addition formula. So we use addition formula, say when we have an angle of 30 degrees plus an angle of 45 degrees, and we want to work out what the sum of those two angles are in terms of sine, cos, and then lastly in terms of tan. Okay, you might look at that and say, okay, well that's going to be as simple as we know that sine of 30 degrees is a half and sine of 45 is 1 over root 2. But it's actually not that simple at all. And we need a whole separate formula to help us find what that value is going to be, and that's what we call our addition formula. So the first thing we need to do is kind of look at our triangle. So we've got a whole lot of separate triangles here within this larger triangle. What we're trying to find is what the coordinates are going to be, or what our sine and cos are going to be of this bigger triangle BAC. And what we really want to know is what would be our vertical height at B, that's going to be sine, and what's our horizontal value. So I'm just going to highlight what we're wanting to find. What we want is, where's my highlighter? Here it is. We want to find what's going to be the length of this side B to C, and we want to find what's going to be the length of this horizontal side A to C. Okay, and once we found that, then we found cos, which is horizontal, and sine, which is vertical. Okay, so that's going to help us a lot. So in order to do that, we are still looking at unit circle. So A to B still has a distance of 1 because that's going to coincide with the radius of our circle. E and F, they're going to fall kind of outside the circle, or we can't really assume that they are on the circle. So we can't say that, say, A to E has a radius of 1 or that A to F has a radius of 1. But we do know that A to B is because that's within our unit circle. The next thing we know is, and I'm just going to look at this triangle on the side here. So this is my triangle A, B, E. Okay, and I'm going to put it in blue. It goes from A to B to E, this one here. And we have a right angle at E, and we know A to B equals 1. So using this triangle, we can find a length for our side B to E, and we can find a length for our side A to E, because we know that our angle beta is at A, and B to E is our opposite. So we know we can find our opposite by finding sine of beta equals our opposite divided by our hypotenuse. Now, our hypotenuse in this case is just 1, so our opposite is equal to sine beta. So that means that that length right there is sine beta. So from B to E, I'm going to draw it in blue so we know where it's come from. That's going to be sine beta just in there. Okay, we can also find A to E, which is going to be equivalent to our adjacent side, and we can do that in the exact same way. We can say that cos beta equals A over our hypotenuse, and again, your hypotenuse is equal to 1, so cos beta is equal to our adjacent. Okay, so cos beta equals to 1, and that is our horizontal length from A to E. All right, I'm going to pick a different color. Let's go with red. And we're going to now look at our triangle from AEF. And we can look at this one now because we have a value of that A to E there. Okay, so if we look at our AEF, guys, you're going to have to bear with me a little bit now. It's like an hour past my bedtime. I'm well and truly fading. Okay, so we've got here A, E, and F. That's our big triangle. Not that it's representative in my drawing, but that's okay. And we've got cos beta along A to E. Now we can use this and the fact that we know that our angle at A is alpha to find E to F and A to F. So E to F is our opposite. So again, we're going to be using sine. So sine of alpha equals O over cos beta. That's our hypotenuse. So therefore O equals sine alpha times by cos beta. And again, we're just going to be multiplying across. Okay, so e to f, in this case, is sine alpha cos beta. We can also find our a to f in a similar way. So again, we're going to do our adjacent divided by our hypotenuse. So this, in this case, it's going to be cos alpha equals a over cos beta. So that means that our a to f along that red line, that's going to be equal to cos beta cos alpha. And again, it doesn't matter which way around those are. It could be cos alpha, cos beta, could be cos beta, cos alpha. We're multiplying, so it doesn't matter. The next triangle we're going to look at is this little one up in that top corner. It's going to be our BDE triangle here, and the right angle there is a D. We know that B to E is sine beta. And we also have a top angle of alpha. Now that top angle is alpha because it's kind of on those parallel lines compared to alpha here. So if you can imagine that we have parallel lines heading through here, we would have those kind of vertically opposite angles, or not vertically opposite, what do we call them? I hope we call them Z angles. We'd kind of have Z angles between there. So we have a similar triangle between BDE and AFE, okay, because they've both got alpha, 90 minus alpha, and 90, so they're similar triangles. Okay, so we can find ratios for B to D and D to E here. So if we're first looking at D to E, again, that's our opposite. So we're going to have sine alpha is equal to our opposite divided by sine beta. So our opposite equals sine alpha sine beta. Okay, that's D to E there. So sine alpha sine beta. And then we can also find B to D, again, exactly the same way. We're going to have cos alpha equals A over sine beta. And so A equals cos alpha sine beta. And that's our little side B to D there. We can have cos alpha sine beta. Okay. From here, we have actually worked everything out. So I'm going to use purple just to highlight so we can see where we're going. So if we want to know our vertical distance from C to B, we can first take E to F, because this is like a rectangle here. Okay, so they're the same. So we can take E to F, which is, so B to C equals sine alpha cos beta. Okay, and we can add on D to B, which is the rest of that vertical height, which is cos alpha sine beta. So we can have plus cos alpha sine beta. And we can also rewrite that as sine of, again, sine's vertical, so sine of alpha plus beta equals sine alpha cos beta plus cos alpha sine beta. That's that angle there. And I'll rewrite these again in a second. The next one is to find our horizontal. I'm going to use, it's a good color I haven't used yet. I use dark green. We're going to take our whole A to F, which is cos beta cos alpha, and we're going to subtract this little sine alpha sine beta. Okay, so we can say that A to C is going to be that whole big line of A to F, which is cos beta cos alpha, minus that little one of sine alpha sine beta. Excellent. And again, we can write that as cos of A plus B equals cos beta cos alpha minus sine alpha sine beta. Okay, so I was going to prove tan tonight, and I kind of got this ready, but I'm feeling too tired. So what I'm going to try and do is do tan and do a couple of other examples tomorrow for you. If you would like to have a go at proving tan without my assistance, then this might be a good starting point for you. But I'm going to head off to bed, and I will put up another video tomorrow with the examples from your workbooks. Okay, have an excellent evening. I'll see you guys tomorrow.